going to have a little look at the following. So we'll talk a little bit about design and creativity within the technologies curriculum, and many of you are, I'm aware, CDT teachers, so you're really involved in these E's and O's all the time. Primary and early years colleagues, it's one of the many curricular areas that we look at, but it's how this fits in the broader picture. And we all are really creative as teachers and as practitioners, so it's how we can all use this. We're then going to talk a little bit about the design process, and that it isn't something abstract, and it is probably something that lots of you are already using, and that lots of our learners already apply sections of it, but it's more just addressing where it fits. We're then going to look at how we turn all of our amazing innovative ideas that we and our young people might have, and how we turn them into representation visually. So that might be a 3D model, it could be an image online, it could be a physical thing. And then we're going to focus this afternoon on Tinkercad, and that's the main tool, but I am also going to show you a couple of other places you can go for next steps depending on the types of devices that you've got. And then lastly, I thought I would give you a little look at the next steps of where you go after this and what the next developments are that are already happening and are already available, and then where you can go for professional support and learning. If there's anything on there you thought we would cover and you would like us to look at, please do let me know and we can pop it in the chat, and Donna will let me give me a wee update. Perfect. So I can see a little bit that we've got lots of primary and a mix of primary and secondary CDT, and some people already using it, so that's super. Okay, so this session is going to look at design, and it is going to introduce people to Tinkercad, but hopefully there'll be something in here for everyone. So I just wanted to put this in a national context. So we have key documents that range from our youngest learners right the way through. And obviously we've got our technologies curriculum. I wanted to flag up what digital learning might look like. I'm really hoping that you've all seen this document. The next slide has a link, don't worry, and this presentation is available in PDF at the end of the session. If you haven't seen what digital learning might look like, I would suggest that you take a look. It's a really lovely document that gives you lots of inspiring ways that you can apply the technologies E's and O's within your setting. At the moment, it's early to second level, but please do take a look. It's a really nice way to be inspired and to maybe think outside the box, particularly if you've got a new stage, or we've been using digital tools in lots of ways because of lockdown, and now we're back. So this might be the next steps that you're looking for, and where do you go next now that we've all upskilled ourselves a bit more as well. Also, just to highlight all of the stuff I'm talking about here, 3.3 in Higgius, our school leaders, Higgius is the backbone of what we're doing, and that's what is inspected. 3.3 talks about creativity. Nothing that we're doing today is anything other than creative. So it really does tackle these statements within Higgius. And we've also got this relatively new compared to the others document called Realising the Ambition for our younger learners. And so for practitioners who do work in early years, I'm going to talk about that in a minute. But just if you haven't already seen what digital learning might look like, please take a moment to scan the QR code. As I say, this is hyperlinked and you'll get it afterwards, or you can check out on the internet of the hashtag that's on the screen. So, technologies E's and O's that we're going to focus on. So the whole session that we're looking at today, depending on how you apply it and what tools you use, and obviously we're looking at that progression because we want our learners to be introduced to things gradually. It's not that we're saying in nursery the concepts would be exactly the same as they would be in PS2. So we're going to focus on how we explore representation of ideas, how we experiment and create products and concepts, and then how we're going to look at creating a graphic representation of that by drawing, sketching, how we create a 2D model or a junk model, and then we're going to move into the 3D modelling through Tinkercad, and I'll talk about that in a second. But within the broader technologies, aspects of what we're doing also link into all of these E's and O's. So some are digital literacy, some are building up all of the organisers we can touch upon. So it's not just that it's one experience and outcome and one set of benchmarks that we're looking at. Aspects of these constructing models, we're doing lots of these things already, but this is the next step of it. This is readying our young people for a digital environment, because I am the first one in a school to get straws out and get the marshmallows and join them all up. But we also need them to understand, we're looking at them to be able to move into the workforce. And these are tools that are not just for architects or engineers, they're for lots of different professions. So giving young people these skill sets allows them to think creatively and problem solve in lots of new ways. It's also a really valuable tool for my primary colleagues. It's a really nice way to start thinking about like the environment that story writing can take place within. And I'll talk a little bit about that later. And if I forget, somebody remind me. And just, I think we had a few early years practitioners signed up. So just if you haven't seen this document, this statement, and I think actually, although it is for our younger learners, I think it applies to everybody. Digital technologies provides opportunities for us to design a unique learning space for children. But the next sentence, bringing resources and experiences virtually to the setting can lead learning beyond what was originally planned. So often when we think about experiences being virtual, we think about VR headsets, and rightly so, Google Cardboard and all these different tools are out there, and they're phenomenal at bringing experiences that might not be available. But with this, not only can our young people access models that many organisations may have available, and if you are doing topics and things like that, there's a wealth of resources available on the internet, and I will cover this in a little bit as well, but you can work with museums and libraries and galleries, and they often have these models that they can email out to you. So, you've got that artefact within your classroom. And I think Dawn, if Dawn is okay to pop in a link, if you want to know a little bit more about creating models, later on we'll talk a little bit about how you would use these models within your classroom and within the design model. But our young people can experience the world virtually by designing their own world, and I think that's the really exciting bit of this. Okay, so what is design and creativity? So design, that's not a typo. Design is a plan of action created in response to a situation or a problem that needs solved. And that is by a lecturer from an American university. That's his exact statement. And obviously Education Scotland has a phenomenal range of creativity resources, but creativity is the use of imagination or original ideas to create something. And whenever we're looking at a design project, we're giving our young people skills so that they are having to collaborate with others, they're having to use critical thinking, and they're having to look at problems that might be inherent, so directly contributing to the character of what they're doing, or it might be a design problem that's imposed, so basically characteristics of what they're doing that are not essential, so like flappy fabric on something that keeps getting snagged. That's a good example of that. Okay, so we're going to create some stuff. But design thinking in its core has creativity at the heart of it. And this model is from Adobe Creativity. If you haven't seen the Adobe Education Exchange, I think Dawn's going to pop the link into the chat for us. I would highly recommend it. They have lots of resources. Creativity is at the heart of any kind of design. It doesn't matter if it's design thinking in its truest terms, and if you want to go and do some research around design, I would recommend you start with Tim Brim from IDEO. He has a really nice meta model of design and design thinking, and what you will discover is there's lots of variations of what design thinking is and how many stages it has. But at its heart, design thinking has three different core concepts. So desirability, what is it that's wanted? So that's like your big thinking. So, the outlandish big ideas where we all think, we're going to want to build a house, and we want our house to have this and that and the next thing. And then reality hits about what can feasibly be done with the space that we've got, more realistically also the money that we've got. So how viable how feasible is what we want to do, and then how viable is it? How will we do it? Who are we going to need to help us? What is the process that we're going to go through? So design thinking is made up of these three core statements. Artistic design is made up of balance, contrast, emphasis, and there's principles of design. There's 8 main principles. And if you want to know a little bit more about design thinking within an artistic design context, there's a session coming up for the V&A in Dundee, and Dawn has already popped it in the chat, so thank you so much, Dawn. If you're interested in sort of the artistic design, and that would apply to CDT as well, because obviously, you know, many designers have their background in creating furniture and creating all of these things out of natural products, and it's an intrinsic skill that they would need if you're an artist, so please do maybe consider that session. And then engineering design, again, we have to look at the desirability, feasibility, and then we look at the structure of what they're creating and how the adaptiveness of it, and what we can trade off to make sure that we still have, for example, a bridge, but perhaps it doesn't have all the bells and whistles that it was going to have. So as I say, creativity within design is key, and we have these 3 main principles. And if you are interested in this, as I say, I really recommend the Adobe Creativity, and there's a link at the end of the presentation to that section as well. So my other colleague, there's lots of my colleagues on this call. So Louise is on this call, and Louise has been doing lots of work around metacognition. But one of the things that the EEF have done, and if you haven't checked out Louise's webinar on our YouTube channel, please do. Our self-regulation session is really good. But our learners, we want them to be independent. We want them to have a skill set that means that whenever they're doing it, they have strategies to develop their work. And that's the same if you're working to create any kind of design piece. So within the independent learning strategy, you would have plan, monitor and evaluate, and our young people would progress through this, and it tends to be more linear, but we revisit each stage at that as they need it. And our young people can apply this themselves. But what we look at when we look at the
design process,
so we can look at plan, research and develop, then apply what you've understood and you've researched, go off and review it, see what people's feedback is, then do some research and development, essentially, reapply it and complete. And we can see that actually
the design process follows
that quite nicely across. So even if your school is looking a lot around metacognition, we're giving our young people these strategies and they apply really nicely over to the design model. So it's worth just having a little check into that. But within that, they're the big sweeping statements. We plan our project, we do the research and development, and then we review, apply, and then we complete it. But within that, there are much more granular stages of design. So we always start with inspiration, and whenever you're doing anything, giving our young people time, space, and the opportunity to be inspired, whether that's a home learning activity, so rather than create the plan or the outline at home, actually go and take the inspiration section of your design, your stage of design, and get inspired and come back. Then identify how you're going to structure your project, how you're going to identify your constraints that might be there. So it might be time, it might be money, it might be the resources available to you within the classroom or within the setting. Then you're going to look at conceptualising it and creating a concept map. So we're all probably really, really familiar around creating a mind map around our IDL or about topics, and our young people will be familiar with doing that with us or by themselves as part of their independent learning strategy. But it's really a useful tool to be able to get a visual idea of what you want your design to look like. Exploring it, testing it out, building diagrams, tweaking it essentially, and then modelling it. So looking at your design brief and seeing, where am I addressing this? What materials am I honing in on the specifics? And then there's production. And you'll notice I've skipped communication, but That's really crucial. So if you are primary, perhaps more than secondary, although I know that there's some phenomenal enterprise projects go on in secondary departments, communication is much more industry standard within the stages of design. But if you are doing a design project and you want to sell the product, the communication stage is maybe doing pitches to get funding, or write that bit where we write letters out to your community. So building in those literacy skills, and design has huge footsteps in numeracy and maths, as well as it can have huge footsteps in literacy too, and art and design. So I'm going to stop there because I've talked a lot. They're the core principles, and then obviously we've got our granular stages of design. So I mentioned design concept map. So if you're not familiar, I thought this would be a handy one to do. So this was one for a chair. So I thought about a chair, and then I looked at what it has, what it needs, and what it is. So a chair has function, and that's identified up in this orange section, and it can have two functions. So is my chair going to be decorative, or is it going to be just designed for comfort? So, you know, when you maybe go and you see something that looks beautiful, but it's horrific to sit on. So I would always choose comfortable. And then is it going to be ergonomic, or is it going to have a specific cushioning? We're going to use our design principles to create something. And the focus of this afternoon session is looking at Tinkercad. So we're going to create a 3D model, but I thought it would be useful to give you a context if you're not familiar with using 3D modelling, where it is used and how it can be used. So here's some examples, and you can all read, so I'm not going to, it's on the screen, so I'm not going to read them all aloud, but just some examples of that would be, for example, in the film industry, if you think of how expensive it would be to blow up lots of cars for a James Bond movie, they are not real. It's all green screened, and there's points put on a screen, and everything is rendered. So a model is created online in the CAD software. It's then given a skin, so covered over, and it's there. So there's lots of applications for it within manufacturing. Car designers, if you think how in the 70s and 80s how expensive it was for them to build a car and replicate it before they even decided if that was the process that they wanted to go down. So again, using CAD software and creating models of these things is a much more financially viable, and it allows for a faster turnaround with reduced impact on the environment. And then we've got things like heritage, so capturing it so that we can use it in the future and interact with it. City and town planners, fashion, again, same principles of rendering something, checking it out, and also digital printing and using that to print and create objects or create the pattern on an object or an artefact. Within tourism, so building up a map, so looping it all together, creating it around, and then in art and culture, so there's lots goes on around modelling in arts and culture, be it the creation of a piece of art or be it the capturing of it so that it can be preserved and kept carefully. So there's lots of these, and again, if you're thinking of, you know, careers weeks and things like that, these are really, there's lots of people that would be happy to come and speak to you, and if I can ever be of any help in kind of flagging up who you could maybe contact, I'm happy to do that. But your local SDS, skills development team or young workforce, they would, I'm sure, be able to give you pointers too. So why do that? As I've said, why are we going to use models? It allows for problem solving, supports collaboration, it allows them to see the whole design process in action. For younger learners, people with accessibility issues, or for anyone with, like, for example, motor issues, where handling something that might be fragile could be maybe something that isn't possible because of the cost attached, if it's like a 7,000 euro artefact. It means that you can have a virtual piece, or you can have it printed off, and so if it's dropped, it's not the end of the world. Also, if again for accessibility, it removes barriers. It means that we can travel to places and we can see things, and it also brings our objects to life because we can animate them. So 3D models are representations of an object. It's a mathematical representation. It's meshed together. It's basically captured in a range of ways, and it's captured by a range of people if it's a scan of something. If it's been made fresh, for example, if you wanted to make a cartoon character and you wanted it to be in 3D, you employ somebody like a 3D modeler or a 3D artist, and they work in the games industry. And in Scotland, we have a huge industry that's around that. So, lots of gaming, lots of film and animation links here. So again, there's lots of opportunities for our young people to engage with this. So there are two main types of models. We're going to look at shell, the second of these, but the two types are solid. A solid one lets you see the entire infrastructure within something. So for example, medical simulations use that, so you can see the heart beating and you can see the blood flowing and things like that. A shell model, the best way to describe that is if you built the frame of something out of like coat wire or pipe cleaners, and then you drape a bit of fabric over it so you see the outline of it. It's what's called a topology. So it basically, in the context of a 3D model, the mesh is referred to the surface geometry, so the shapes that's put on it. And these can be used, so you can create 3D models in a wide range of ways. So there's software like Tinkercad that we're going to look at in just a second, and then there's things like Blender. Code Club have a huge range of resources for Blender. It's free, it's web-based, you download it, it doesn't seem to capture any data at all, but as with any product at all, please speak to your local authority team to speak about which products you have permissions to use for GDPR and things like that. We want everybody to be compliant. There's obviously, if you're secondary, you'll be really, really familiar with Autodesk, and Autodesk actually bought Tinkercad over a few years ago, so it's owned by them. And then there's mobile apps like Gravity Sketch and Microsoft Paint. So if your school has Windows 10, you have Microsoft Paint, and we've got some webinars that have evidence of that in it. We're not going to cover it, but I'll show you where to get them. Let's move into a live demo. Tinkercad is web-based. You don't need to download anything, and you as the teacher would need to sign up for it. Again, please do contact your local authorities for guidance around this. One of the nice things about it has these really clear icons at the start, and I just want to cover these quickly. So when you're looking at this, first and foremost, I would suggest that you enter via the Teach section, and it has a huge range of stuff. So it comes with free lesson plans, and they are really good and structured. One other thing I should point out is, although we're just looking at 3D design and the design aspect of it, it allows you to have virtual electronic kits, and it also allows you to code your models. So it has code blocks and it has electronics, and these work on digital sandboxes, so you connect up the thing. So I used to teach in primary, and my class, didn't matter how often I used to check them, we'd always be missing like an LED, or we'd be missing something, or a bulb had gone, or a battery. This allows you easily, and especially just now when we're maybe having to clean products more before we can use them, this is a really nice way to continue that educational development without so many risks of using materials. So just want to flag that up. Also in here, it has a range of different resources that you may want to use, and it has some example projects that you can take a look at too. It also comes with some fantastic posters that I really like, because, paper and pencil is where you start. It's not usually digitally. With any model making, you always start really with paper and pencil, and especially if you're doing reverse designing. So and that's where you start with an object and you basically backwards design it. So you work out how it was put together and how it works and how it fits a brief. But for this one, it lets you see where all your activities can fit in. And there's another one that I'll show you that talks about how you can talk in 3D. So these are all available through Tinkercad for free. So when you are in though, this is what it looks like. So you would have signed up with your Glow account if you want to, and your authority gives you permission. And you can do two things. I would suggest that you basically start to tinker yourself, which is create a new design, which we'll do in a second. Alternatively, you can go up to the corner, which is your little icon, and you can choose classes. So within that, you can choose classes, and I'm just going to flip out into this one to let you see, because I've got a couple of accounts. So go into your class, and you can see I've got 2 classes created, and then I can put it in. And the way I did this was with the class I was working with, I basically gave all of the kids a number rather than use their name. And when they log in, they needed a different number, and I gave them a passcode that let them in. And you can see there it says seat. That basically means they're a member of my class. If I delete their account, all their work goes with them. They're part of that class. That's the only way that their account works. It also, just so you know, if you are using this with your class, it lets you see any designs they've created, and it also lets you see when they last logged in and who did what, and you can block them if somebody's maybe been inappropriate, or somebody's maybe not quite understood the design brief that you're showing. You can block them for a while until you've had that chance to have that dialogue with them to make sure that they're on track and that they're having a positive experience with the resource. Okay, so whenever you want to go back, you just hit your Tinkercad button up here, and any design that you created will appear here. So to create a new design, we're going to just click create now. And just while that one's loading, because my internet's not super fast today, I want to highlight this. Down the side, you've got this whole option here. So this is another way that you can access the circuit section, the code blocks. But when you're doing this, if you wanted to set your class a challenge of maybe working on this and completing a set of really basic resources, lessons, just so that they get the core skills, which is kind of what we're looking at today, it has 3 core lessons. And then once you've got those 3 lessons complete, you can kind of build whatever you want. So it has these lessons that take you through step by step within it. And you can also search for your design by name. So if we go into, back to my other account, there we go. So you've got your work plane, which is this bit along the bottom, and then you've got a little menu at the side. I just want to check that you can see that. Okay, yeah, you can. So it has a range of control options. This box here allows you to tilt your work plane around just so you can get a better view of your design. You've then got your home view, which kind of resets everything. If I pop in a box, if I just grab it and slide it across, if I want to zoom in on that and not any other part of a design I had, I can then zoom in using this fit view 3D box here. And I can zoom in further or zoom out. And then this one allows me to change my perspective. So you'll see that it allows me to move around and see it from different avenues. So it's really, really simple. If I pop something on and I don't want it anymore, I simply just hit delete, select it and hit delete. So I'm just going to zoom back out and I'm going to go to home view. Okay. So within our Tinkercad activity, I thought this afternoon, I'm just going to take you through it because you'll all have your own ideas, but you can create essentially anything within it. And I flip back and forward so many times I don't know which account I'm in, this one. So if I go into one that we already made earlier, I made a chair for us. So you can see here, you can tinker something really simple or you can tinker something really complicated. I'm just going to do some quick things and then you can go explore later at your own convenience. But you can see here, I built this really quick stool that would hit. So my design brief would have asked my young people to create a piece of furniture that was functional yet fitted in with the modernist piece of architecture. So we've gone for these big geometric shapes. Maybe it's to do with Bauhaus, so we could look at different colour designs and things like that for MD. That's maybe here from art and design background. So to design something, I'm going to show you, based on the fact that we've got a mix of primary and a mix of secondary, I'll start with something really simple. So whenever I drag an item on, we'll just start with a quick keyring and then we'll build something else. I'm going to choose one of my geometric shapes from the side, and then they're known also as primitives. So just in case you see that written anywhere and you're not sure. I'm going to pull it up and I'm going to change my view to fit the view. Whenever I click my box, you can see I've got editing boxes, just like I would in a Word document. All I'm going to do is stretch them until I get to the size that I want. So I want my keyring to be about 2 centimetres wide. I want it to be about 1 centimetre tall, and I'm going to stretch it there. So I've now got this little box that I'm going to basically carve stuff into. So I could build up my shape like I did here. So you can see if I click on this, it's just made of lots of component shapes. But I'm going to simply, I need a keyring holder. So I need where the little loop's going to fit. So I'm going to choose a cylinder. So again, for my young people, we're starting to talk about 2D shape, 3D objects. We're talking about measurement. You'll notice I'm speaking in millimeters. So again, if your young people are at that stage, you are moving from centimetres to millimetres and you're discussing that with them, there's a little grid at the bottom. You'll notice I have it on snap grid. That just means it aligns really neatly to the work plane and it all snaps into place, but I can turn that off. So I've pulled on my cylinder and I'm going to squash it down. I can check the height of this by going to the middle of my item and it shows me that's still 1 centimetre deep. I'm going to pull this over and whenever I want to lift it, I use the top hat. So, oops, there we go. So now I've popped this in, but you can see that it's not quite the right size, so best laid plans. I now have a space on it that's going to be the hole, and all that I do in Tinkercad, it's a lot easier than some other products, is I basically tell it I want it to be a hole, and that's done by this little drop down menu here. So I've got my shape, I've pulled that on and I can look underneath and I can see actually, do you know what, it's not deep enough, so I need to pull it a bit more. And I can make sure that it's on my work plane. When I'm happy with my design and I've made it to the depth that I want it to be, I can then go and pop something else on. For example, I can pop a word on. And the way that works is you just grab the text box, you place it on the work plane, you slide it to where you want it to go. Again, looking at your different measurements. And all that you do is in this box here, you would type it. So I'm just going to pop in Jen. Now you'll see it's the same colour, so it's not that easy. So I can change the colour by selecting a solid shape, or I can use a custom shape. I can't use multiple unless I do them letter by letter, which you could do if you wanted. Once you have that and you've selected the font that you want, you're simply going to move it to where you want it to go. You might want to check your view, check that it's where you want, and I want this to kind of engrave but not go all the way through. So I'm going to tell it it's a hole as well, but I haven't gone all the way through. No, I have. So I can do two things. I can make it shallower, narrower rather than my keyring background, or I can raise it up. So now if I lift through, you can see it's not there, but I can see where it is. It's giving me if I was using animation terms, it's giving me an onion, so I can see the shadow. So now I've got, if I just go back to home view, I've got a keyring that I can print out. It has my name on it, but I want to group it together. So I might want to do this. And up here I've got a whole range of tools. So I could use symmetry, I can align everything down one side. For this though, I want to group it. So that means any future changes will affect all of my items. I can ungroup it at any time I want though. And if I wanted to put some notes on it, so if I was asking my young people to complete a piece of coursework, what I might do is say, okay, I want you to do this piece of work, I want you to fill this design brief, and as they're completing their design brief, they're basically going to drag on a note and give me some feedback about maybe texture that they would want to use or fabric that they might want to add in at any time. Or if they were recreating something, you know, if they were recreating something that was a geographical landmark or an item from history, or even if it was so I mentioned storytelling, if they were building up characters that they wanted to use in a fictional story, they could give me their adjectives to describe the character or the place that person lived. If I don't want the note anymore, I just get rid of it. So to create something on here is really simple. If I wanted to create something else, for example, with more detail, and I'm sure you've all kind of got the idea, but I'll just go through it. Is there any questions just as I'm doing this, Dawn? No. Okay. So if I wanted to recreate my stool, for example, I'm going to choose this half sphere. I'm going to flatten it so it's still slightly domed so that it's got that cushioned sense on it. And I'm going to rest that on top of a cylinder. So I want a flat piece of plyboard to be underneath, and then I want this to be on top. So I'm going to check the dimensions. So it's obviously mini, maybe it's for small world play. And then we've got the same dimensions, so that 2 by 2, so 20 millimeters by 20. Slide it over till it's on top. Use your cone to drag it up, making sure they're still touching, and they can check that by doing two things. One is zooming in. If I'm printing, it's really important to have a slight overlay so that the printer attaches them both. Sometimes if our young people make a little gap when they're printing a model, if they want to print a model or have the capacity to do that, then sometimes the gap means that the print kind of fails halfway through. So I can pull it up. If I wanted to have this at a slight angle, so perhaps this time I want to have a more beveled back. So I'm going to, instead of my triangle, I'm going to have this one. So I'm going to need to turn it. So you'll see that I have these arrows that are on the X, Y and Z axis. So I would just turn this up until it's at 90. If, again, depending on the age, stage and ability of your young people, they're not quite there, you can just type in the box and it will do that for you. So, and I've managed to turn it. So I'm going to raise it up, making sure that that number is 0. That means it's on my work plane, and I'm going to just twist it round so that it is where I want it to be. I'm going to align it, and I'm going to use my little work plane manipulating tool to twist this round. So I'm going to pull it forward, twist round, just using that box. I need to have enough room for my chair to be comfortable. And again, this, when we think back to that exploration and refinement section of the design process, because again, it's not linear, it is that whole flexible model, I can pop that in here. I can also narrow it down, so I don't want it to be so pronounced at the back. And then when I think I'm happy, drag a box with my right click. So with your mouse, if you have I'm on a Mac, so it doesn't have any buttons, but if you have a button, control left means that you can zoom in and out, and control right means that you can rotate the view. But if you just simply right click and drag a box over the top, as you can see there, that's the bit that allows me to group everything together, and it will take on one colour for them. So now I'm going to really quickly pop on some legs. These are ridiculously big. So I'm going to make, because my chair was 20, make these half. Oops. 5 by 5. Okay, so I've made them 5 by 5, and I'm going to make them 15 tall. To save me making this 4 times, I can Control and D, just like I would on Word, for example, and I can make a copy of that. I can then grab both of them, Control and D, and make another set. So again, I could be really pernickety and I could look at counterweights and things like that. But once I think I'm happy and I've got my 4 exactly mirroring legs, I can then have those posts. Simply grab my item. I should have checked, oh, they were 15. So I now know that I need this to be about, well, 14 and a half would probably be perfect. So I'm going to go 14. So that there's a little bit of overlay. Sorry, everybody, make you all seasick. And then I'm going to just slide that over. When I think I'm happy, I can check it. I might want to look at it from underneath just to check that my legs are not like sort of hanging off the edge, looks okay. And then I can press home to go back. And with that, my young people have created the design that they have sketched up, written up, thought about, tested out different models using junk modelling, wooden blocks, loose parts, all those kinds of things. Really, really simple. If I wanted to put a pattern in it, for example, studs or things like that, I would just basically continue the same principle. Maybe I want to have dimples in my fabric, something along those lines. So I'm going to create a really small ball. I'm going to zoom out a little bit. This is where it might all go horribly wrong. There we go. So I'm going to just squish that down, pull it here, and use that cone just to drag it up, and then drag it until it appears here. So I could repeat this, we're not going to just for this, but I could give it some sort of artistic effect at the back just by making that hole. And if you're making something like windows, that's the principle that you would use. So if I go into here, when I come out of this, I'll change it and I'll show you about the houses, but you can rename them. So your young people would select the name. It automatically generates a name. I did put that one in yesterday, but it'll give a name. So everything is named, and then you would just do whatever you wanted to call it. And it my favorite thing about this is it's a bit like Office 365 or things within G Drive. It just saves automatically. There's no clicking anything, or if somebody's got to leave quickly, it's always there. So that is how you create a model. I know it's a very swift tour of it. I'm going to show you a couple other really good features. Useful are looking at doing some freehand stuff. There's a really nice tool. So I made some trees earlier, and because I made them all as one part, the whole bit is green, but we'll just say it's moss, and that's okay. So you can see there I used a cube and I stretched it out, then I gave it a square base pyramid and I put a roof on. I used a cylinder and I popped a cylinder in the middle and made it a hole for a chimney, and then I drew some trees. So to draw some trees out of all of the tools that you have here, and you have other tools in here as well. So if you're doing a sort of circuit section, you do have a list of components that you can involve. There's also some skeleton parts, a dinosaur, super cool, but we're going to stick with basic shapes, and in here we've got this scribble button. So if I select scribble, drag it on, and you can see I've got my work plane here. I've got very simple buttons at the bottom, and all I'm going to do is freehand it and then fill it. So if we just stick with the tree, just for the sake of drawing a little tree, we'll do wee squirrel. There we go. Bear with me, it'll look more tree-like when I'm finished, I promise. And then we're going to fill in the tree. So I'm just going to go all the way around, all the way around, all the way around. So we've got this handy wee tool. If you want to just freehand it, you can just draw. And the more you zoom in, the more you allow for extra details. It only allows you to do this in one colour. If at any time your young people make a mistake, they can undo it, or they can clear their whole board. Once you're happy, click done, and your freehand model is there. So if you think about, you maybe want to create artistic features on a piece of furniture, or you want to put in dovetailing, and it's quite hard, some people might be finding it hard to do on their model, but you want them to show that that is the joint, they could use this, but again, it's really nice for just sort of a little bit freehand. And if you've got devices that have pens and styluses, is a really good way to kind of incorporate something that might be more mouse-based. So I've now created my tree. I'm going to make it a bit flatter, and I'm going to use, again, my X, Y, Z axis, and I'm going to just flip it up. The way I made those round ones was, first of all, I changed the colour, and then all I did was Control D, move it, twist it. Control D, move it, twist it. And then you're just basically repeating that until you end up with the sort of tree shape at the top. We're short of time, so that's how you get that. One wee thing I should show you, you can copy anything that's on your model as well using these icons here. You can remove anything on your model using this, and you can undo. So you have all of those features, but over at the other side we have some additional features. So up at the top we can recreate, so if I just select everything, you can recreate your model in Minecraft. It shows you the type of blocks that you've used, and you can change how sort of grainy and blocky it is using these different options up at the top. So it lets you see, and you can also remove the ground. This can be exported and put into Minecraft. So your young people can create something that's not in Minecraft. If you are using maybe the free trial licenses, etc., then that allows them to build something, import it and put it in. They can share it with their peers and they can share it with their teachers, but you will automatically see it because it's in their Tinkercad account in your class. But my favourite one is you can build Lego bricks. So whatever your model is, once you've created it, you can again build it. So you have Duplo size, you have the creative bricks, I think they're called, and then you have the really fine ones, which are the Lego architect bricks. The only thing with the Lego one is that you can share it, but you can't print it now. That doesn't allow for it to happen. Again, they can invite to co-collaborate with any of their designs with a person that's maybe in their class, or invite their teacher to use their teacher to come along and maybe work on their work with them. Once you go back, and we're now using this 3D design, I've got 3 different options up here. I can send it somewhere. The main thing that we're going to look at is exporting it, but I could import a model. So if you've got a model that somebody's already built and you want to incorporate that as part of a design, you can do that, and it will incorporate OBJ files or STL files, which are the most common. To export your file, you simply select this, click OBJ, STL, or if you want to put it in PowerPoint, a GLB, and I'm going to show you that next. That then saves. When I save my file, I have a model that I can interact with. That allows me to put that into a PowerPoint. It allows me to put it into whatever else I want to look at. So once I've done that, if I just quickly nip back into my presentation, because I know that we're short of time, all I would do is go to Insert and 3D Model. So hopefully you can all see that there. So 3D model, and then I've got it here. So, and you can see I can interact with it, and that works for this. So again, if you're doing that pitch thing where we talked about communication, sampling products, etc., you can also use the built-in models. So this is not one I made, obviously, but it allows you to see. So we've covered what design looks like, where you can apply it, what the process of it is, and how it works. We've then looked at how you can use it within Tinkercad to create from a concept map right through to free exploration and use of CAD software, computer-aided design software. And then other places that you might want to investigate. So for more senior primary, but probably secondary pupils, looking at Blender, really useful for art projects, or it can be used to create as an alternative product to something like Autodesk if you want to have that progression. It's also nice as a slightly more advanced, it's industry standard, and everybody has their different preferences. So again, it's just a tool that you might want to investigate, but please do check with your authority. Something that's fabulous for everybody, no matter age nor stage, is Microsoft Paint 3D. So if you have Windows 10, please do investigate that. Just search in your toolbar, it's already there for you. It has a core set of tools, so if you've got learners who are just more free exploring, but then you can put it into mixed reality, 3D viewers, etc., etc. Within, I know I'm whizzing through this, but I want to make sure we finish on time because it's you've all been very patient. So the Adobe Exchange, Educator Exchange has lots of courses and resources, and you can sign in with your Glow account. And in here we also have, for the PowerPoint tools that I spoke to you about and mentioned earlier, We have, there's some courses that you might be interested in, how to do modelling within your presentation. So that might be nice if you want to explore that as a prompt for your actual lessons. And there are some resources that support you. There's also a course. If you're an iPad-based school, you may want to investigate Gravity Sketch. It's a really, really nice tool. I've used it for about 5 or 6 years. And it allows you to freehand draw. It has built-in shapes, and this is a pot that one of our colleagues, Susan, created for a different session on creating your own artifacts within your presentation. And I think Dawn has either shared that or is going to share that link if you want to watch that recording. But that webinar shows you how to use all of these. And moving forward, I said I would mention a nod to the future. So while 3D printing, I do love it, it's amazing, 4D printing and 5D printing are already here. So if you are interested in this, 4D printing is something that reacts with its environment. It's got lots and lots of potential. It was created by MIT, and it has lots of potential within medicine, and also to support maybe hard to reach places. 5D printing, for anybody who's interested, is basically the base plate. Rather than you print onto that, it rotates around, and the nozzle head also rotates. Next steps, if you want to know more, please go to DigiLearn Scott. We have a whole range of different resources, webinars coming up, and a link to lots of the stuff that we have been doing. We also have our professional learning community on Glow. There's lots, each subject has theirs, but the technologies one, I might be biased, but it's got loads of amazing stuff. So please do go there. There's a link in the picture, or you can scan the QR code. There are lots of resources that are available to you. If you're on social media, please do tag in DigiLearn Scott if you're doing anything around design or technologies or digital learning. We'd just love to hear from you and see what you're all doing. Thank you all so much for your time, especially if it's sunny where you are. Thank you for coming along, and thank you to all the practitioners who've given up their time. And also there's so many people from our team here, so thank you. Have a lovely evening, everyone.